Assalamualaikum everyone. I'm ELLYNA dan DIPLOMA MOHAMAD, matrix number 2022469416, group 12, part 1 in Diploma Science. In this video, I would like to share and discuss about CHM131 Chapter 1 Subtopic, Limiting Reactant and Excess Reagent. Before we begin calculating and discuss, do you actually understand what is the meaning of limiting reactant and excess reagent? Yes, it's true. From the definition, we know that limiting reactant is the reactant in chemical reaction that limits the amount of product that can be formed. It's entirely consumed during a chemical reaction, while the excess reagent is the reactant in the chemical reaction that remains when a reaction stops, when the limiting reactant is completely consumed. The excess reactant remains because there is nothing for it to react with. But my question here is, do you really understood the definition? Let's have a few analogies to clear our doubt. Okay, and the first analogy we have here is the process of making chocolate buns. Who doesn't love chocolate? Mostly everyone loves chocolate, except you have allergy or something. So to make one chocolate bun, we will need a bun and a chocolate bars. But what if we have 4 buns and 3 chocolate bars? How many chocolate buns actually we can obtain? Okay, let's see on the slide here. Only 3 complete processes of chocolate bun can be made and 1 incomplete process because of the absence of the chocolate bars. That means chocolate bars stop the production of chocolate buns even though there is still 1 bun remain. Hence, we can notice that the bun is an excess reagent whereas the chocolate is the limiting reactant. For reminder here, limiting reactant and excess reagent are not identified based on their amount or value. What does it mean? The second analogy we have here is now making a stack of roti canai. Wow, roti canai! Okay, let's focus. To make a roti canai, we need 2 small packs of flour and 1 bottle of water. So what if we have 6 small packs of flour and 4 bottles of water? How many stacks of roti canai could be produced? Ta-da! Take a look at the slide where we can see only 3 complete processes of the production of roti canai, and also you can see the extra ingredient that are not being used, which is a bottle of water. Yes, in this case, we notice that bottle of water is the excess reagent and small pack of flour is the limiting reactant. Aha, yes. This is what I've mentioned before. Even though flour has larger amount than bottle of water, it is limiting reactant in this process. So far so good? Okay, what if we apply this on the chemical reaction? Let's go! Okay, in obtaining or identifying limiting reactant, you need to complete these 3 steps. Find the mole of the reactant, divide each mole with its coefficient respectively, and comparing the answer. So here we have zinc metal react with hydrochloric acid. From the balance equation, we can see that it producing zinc chloride and hydrogen. And the question asks for the limiting reactant. So what should we do first? Yes, we refer back to the 3 steps earlier, which is the first one is to find the mole of each reactant. In this case, we already have mole of zinc, 0.30 mole, and mole of hydrochloric acid, which is 0.52 mole. So we can skip the first step and move on to the second step. Second step, we need to divide each mole with their coefficient respectively. The coefficient of the reactants can be identified by seeing the number in front of each reactant. As well as you can see the pink circle in the coefficient of the reactant. How about zinc? There's no number in front of it. Is it 0? No. When there's no number, we assume that as 1. So 0.30 mole of zinc metal will be divided by 1, while 0.52 mole of hydrochloric acid will be divided by 2. And we have already settled for the second step. Next, compare. So between these two, the least number will be limiting reactant and the larger number will be the excess reagent. So the question asks for the limiting and the answer will be hydrochloric acid. With that, we've already completed the question. Simple, isn't it? Let's go for the harder one. Here's the tricky question. They ask us to find the limiting reagent, mass of copper produced and mass of excess reagent. Hey, don't go away, come here, solve together. So the first question, they ask for limiting reactant. It's just simple calculation, just like how we did just now with the zinc metal and hydrochloric acid. But in this case, we need to do the first step, which is find their mole. From the equation, we note that sodium has 0.47 mole, while the mole of copper 2 nitrate were not given. Only the mass of copper 2 nitrate was included in the question. So let's find the mole of the copper 2 nitrate. Okay, first we need to find copper 2 nitrate molar mass by referring to the periodic table and then divide the mass with the molar mass. And voila, we have already got the mole of the copper 2 nitrate. And then we will make a table so that we can clearly see the calculation. We will compare the mole, divide each with coefficient and compare the answer. Thus, we obtain that the copper 2 nitrate is the limiting reactant. Okay, to settle the first question. Move on to number 2, mass of copper produced. It might be a little bit tricky, but as long as you follow the step, you won't get lost. So actually, the area of chemistry that deals with the amount of substance formed and consumed in the reaction is stoichiometry. In stoichiometry calculation, the maximum amount of product that can be formed in the reaction is determined by the limiting reagent. So we need to compare the copper with the limiting reactant we obtained earlier, which is copper 2 nitrate. Ratio from equation is their coefficient respectively, as you can see in the purple box on the upper part of the slide. And then we calculate the mole of the copper produced by comparing both substances. If 1 mole of copper 2 nitrate producing 1 mole of copper, then how many mole of copper would be produced if 0.14 mole of copper 2 nitrate were used? So 0.14 mole divided by 1 mole of copper 2 nitrate and multiply with 1 mole of copper. We will get 0.14 mole. But it's not the answer. The question asks for the mass. So we will convert the answer to the mass. To convert, we need to multiply mole with smaller mass, which is 0.14 times with 64. The answer obtained will be 8.96 grams. And yes, settle for the second part of the question. For the third and last part of the question, we just need to compare both reactant in a table, which is excess reagent and limiting reactant. First, identify their mole ratio from the equation, which is 2 mole for sodium and 1 mole for copper 2 nitrate. Then state the mole available for each reactant. Next, we will find the mole of excess reactant. This step is very similar to just now, which is how we find the mole of copper produced. In this case, we need to minus the available mole with the mole reacted to get the mole excess remain. And lastly, we multiply the excess mole remain with its molar mass. In the end, we will get 4.37 gram excess remain for the answer in the third part. Then, we have done for all 3 questions that has been asked. Wow! It's very tricky yet exciting, right? To master this skill, you need to train hard, do extra question and exercise more. If there's the will, there's the way. We've reached the end. I hope you understand my explanation and thank you for staying until the end of video. So here I attached the reference that I used in the making of this video. Visit homework.study.com to get a lot more questions related to the limiting reactant and watch also Saja David videos to have more examples. And I also use a lecture note by Dr. Nurul Izzah for extra information. This cute template were made by Noisy Frame from Canva. I think that's all for this video. Till we meet again. Bye. Assalamualaikum.